Okay, thanks. Bow your heads, please.
Jesus, thank you for today. I thank you for, first of all, for Ms. Freitas, just being able to come and teach this stuff to us. I thank you for this curriculum that we have and for the freedom that we have to come here and do all this homeschool and everything like that. And pray that we'll just get a lot out of today's lesson and that we'll just have a great day today. In your name I pray. Amen.
Amen. Thank you. We're going to go ahead and review what we did last week first, okay? So go ahead and open your books to the beginning of the module, of Module 1. Last week we started with the basics, and we did the experiment, and hopefully all of you wrote that up. Somebody tell me, what was the purpose that you wrote up of last week's experiment?
Atoms and molecules.
Okay, to learn about atoms and molecules. Good. And then the procedure you would just have walked through, that we put the little wires in that was attached to a 9-volt battery into water that was mixed with baking soda. What were our observations? It bubbled. What else?
One of the wires turned bluish.
Good, good. One of the wires turned like a teal color.
The wire turned bluish.
Very good. The water turned a bluish color also, didn't it? And yes?
The other wire stopped bubbling.
Good. Eventually, the teal wire stopped bubbling. Very good. Who wants to give me a shot at a conclusion? That's the hardest part, and I know that. Did anybody come up with a conclusion that they want to share? You guys are looking for your conclusions. Yes, sir.
Atoms are the smallest stable unit in creation, and molecules are made up of two or more atoms bound together. Molecules have unique individual properties from the atoms that make them up, as seen by the copper, hydrocarbon, no longer reacting with the water-like properties.
That is excellent. That was excellent, Tyler. Did everybody hear what he said? That was really good. Let me have it. I want to read it up here, just so they can all hear it. You did a really good job.
I didn't do it quite.
Where'd you get it?
I got it.
You got it out of the book. Well, that's why it was so good. Okay. Atoms are the smallest stable unit in creation. Molecules are made up of two or more atoms bound together. Molecules have unique individual properties from the atoms that make them up, as seen by copper hydroxycarbonate no longer reacting with the water like the copper did. Now, you got the information from the book, but you put this together yourself to make the conclusion because you tied together the facts with your observation. It's perfect. You did a great job. That's just what you're supposed to be trying to do. The fact can come right out of the book because that's the fact you were trying to learn. And then you're going to tie that together with your observation somehow, as seen by, or if the experiment doesn't work, as we should have seen if, because real life doesn't always work the way it should. Okay, so great. That was very good. And I know you think, oh, well, I got it right out of the book, but the trick is a lot of people didn't get it even with the book there. So that's why you did a really good job. That was good. Good. And if you didn't get that, it's okay. That's why we read Tyler's, so that you know what it should look like, is something to the extent where you told me about, somewhere in there you should have had what atoms were, you should have had what molecules were, you should have that molecules have individual characteristic properties, you could say unique characteristic properties, and then as seen by, or that's why we saw, and then you tie it together with the observations that you made. Does everybody see how that works? Okay. And that is the hardest part of a lab. The conclusion is definitely the hardest part of the lab, in my opinion, a good conclusion. Because it should have facts that you've learned and tied together with your observations. Shouldn't just be a restatement of your observations. That's what a lot of students want to do, and I don't want you to do that. Okay? All right. Good job. And we saw that we called the smallest unit of chemical matter an atom. And if we attach two or more atoms, then what do we call it? Molecules. And I told you to don't overthink the questions, that if he has something on there and he says you can break it down into smaller particles, you're going to answer it's a molecule. Okay? Because I know even molecules are made up of atoms, but then you're overthinking the question. So I don't want you to do that. And you do need to remember that each molecule, with whatever change there is to it, including O2 to O3, would be the difference between breathable oxygen and ozone, which is poisonous. So just little bitty differences in molecules make huge differences in whether they're liquids, gases, or solid, and in what their characteristic properties are. So God's got a very cool Lego set. And then we talked ever so briefly about if you have a whole bunch of atoms of one kind, we call it an element, like the copper wire that was attached to the battery was an element. If you have a whole bunch of molecules of one kind in a place, then we call it a compound. So like distilled water would be a compound. And then we said that when we took the distilled water and mixed baking soda in it, then we called it a mixture because we have more than one different thing in the same proximity with one another. And then on page 6, we had a picture from a scanning tunneling electron microscope of nickel. Has anybody really ever seen an atom for sure? No. They have not absolutely seen an atom for sure because there are some ifs involved. And if any of those are wrong, then we really aren't seeing an atom. So we have to keep that in mind. Then we got to measuring units because we have to be able to measure the matter that we see. And we have the metric system and the English system. Which one do we use in science? The metric system is the one that we use in science. And in the we have basic units that we use for different things. Like in volume, what do we use in the metric system for volume? Basic unit for volume. Liters, good, liters. What do we use as a basic unit for volume in the English system? Gallons. You do need to have these in your head for the test, okay? These base units. What about for length? What would we use in the metric system? Meters. What would we use in the English system? Good, foot or feet. Good, very good. And then how about time? What do we use? English. Seconds. Metric. Seconds. Oh, thank God. Okay. And then what about mass? What do we use in the metric system? What do we use in the English system? Slugs. Pretty strange. Okay. Did you have a question?
Oh, no.
Okay. Okay. Oh, in the review, just answer. Everybody just answer on the review. I'll try to keep the answers so that they're short enough that everybody should be able to respond together. Okay? All right. And then on page 11, he explained that in science we use the metric system because other countries use it so that we can put our information down in a written form and everybody scientifically can look at that information worldwide and understand what it is. But also because the metric system is actually a lot easier to manipulate between variables, between sizes, because all you're doing is either multiplying or dividing by tens. Oh, I like tens. They're so easy. You know, you just, it's just, oh. So, I mean, I can do things with tens. You just doing a zero here or there, right? So the metric system makes it easy in that way. And we looked at how to use what he calls the factor labeling method, but I really taught you to do some dimensional analysis last week. And I told you that when you have a problem to do, one of these problems to do, that you're going to read the problem twice. Now, that's not how you start. How do you actually start when you're going to do a word problem?
You pray.
Thank you. You pray. Always pray, 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 pray. Okay, so you pray. Then you read the problem twice. The second time you read it, you're looking for the given and the get to. And you're going to write those down, the given and the get to. Then what's the next thing you do if you're doing a conversion?
You restate the given.
Good. You write the given again. Then what do we do together, class? What do we do? Times line. Very good. What dimension goes on the bottom? What unit? Same one as the given, right? Whatever I have, I'm going to put that dimension on the bottom so they'll cancel. So the dimension that's the get to is going to go on the top, isn't it? Then after we've got that, if it's metric, then we're going to go, who's the big boy? And we're going to give a 1 to the big boy, and then we'll figure out what the other one needs, and it'll be actually a whole number. It'll be either 100 if it's centi, or it'll be 1,000, depending if it's milli or kilo. Okay? And then if it's not metric, if he wants you to go between, which is on page 14, on page 14 he gave you a table, 1.3, that had conversions between inches and centimeters, slugs and kilograms, gallons and liters. When you have those, you just still put whatever the given dimension is on the bottom, whatever the get to dimension is on top. And then to put your numbers in, whatever number is to the left of the unit you're looking for, that's the number that's going to go to the left of it in your funky one that you're building to do your dimensional analysis. Okay? Were you okay when you went home and you worked on these? A little better? Okay. All right, a little better, hopefully. I know, I do these differently than most people, but it works. It just works. and it always works. And it works all the way through chemistry, and it works all the way through physics. So that's why I like it, because I don't have to learn different ways to do it. You know, I know the math teachers have all these different ways to do things, because my husband says, that's not the way you're supposed to teach her, and he'll teach my daughter other things, and I look at it and I go, but my way always works, you know, and he's got all these different ways of doing it, and I'm like, okay, whatever, because he's the math tutor, so I just leave it alone. So, all right, but for science, this always works. And then we get up to page 17. Oh, excuse me. We were on 15, weren't we? On page 15, we have experiment 1.2. That's where we actually ended last week, was on page 15. And experiment 1.2 is actually measuring cubits and fingers. You're welcome. Do the same person on the cubit and the fingers. Don't do different things. That would make me. You can if you can't mark it. You can mark it with a pencil or you can.
It's going to be a lot of fingers.
How we doing, fellas?
Good. Measuring fingers.
You got to share your tape. I'm sorry? Whatever it says. You have to follow the instructions here in case you guys know.
Do it on the tape.
I'm going to give you some more tape just so you guys. No. You'll get it, Connor. It's okay. It's okay. It's the first 2 weeks. Okay. No, we will follow through with all the studies and then. So, did you want to read your test? Well, did you feel like you had to do everything on it? Then don't worry about it. We're going to go over the first module for testing, and then after that, that way you have to. Okay?
Can we cut this dips?
You may cut that, yes. I got to get this. Read. You're supposed to read these before you come into class. You may actually have to get your hair out of your eyes to do that, though. How are we doing? Does anybody need a tape? Or you guys are doing all right? You're using the same person.
Let's start short. That's the end right there.
Come on, guys, work together. I know I'm mean. Next time you get here, I'm okay, God. Wow, how many markers each one?
No, it's 2 hours. They're marking each. Oh.
Black shirt.
No, right here.
Guys, when you measure the tabletop, measure the short way, not the long way. Okay, yeah. When you measure the tabletop, measure the short distance, not the long distance. Because using that little bitty thing, it's gonna, be kind of interesting. So use the short way, not the long way. Okay. This, yeah. The edge. How are we doing, fellas?
Good. 22 fingers in my cubit.
Okay, now you're going to do the next part. You have to measure, I think you have to measure.
Yeah, the point tabletop.
Are you sharing your data or did you write that down? You didn't write that down, Tommy. You're good. How many fingers in a cubit?
He's the one that came up with the data.
That's right, you have to record your data, Tommy. No fraction. And you use the same person. Okay, write it down. You got it. You've already got this done. Okay. Oh, here it is. I need to look at them just to make sure you're doing them okay. But, we got a lot.
It's like one.
Connor made a good point. Bring in your lab write-ups next week so that, I'll try
Did
to
you say
put
that
them
would be
lab.
on top?
I need to look at them while you're doing the lab. Yeah. It's a short lab.
So,
Wait, isn't that the one? That's the one that
Oh, okay, but these are set for next week then. We don't do anything on the other two. Did you feel like you did okay? Don't worry about it. Next time, we'll always do all the class before we have to take it.
fingers.
Well, you're already doing that. So this week you'll do the homework. Guys, this week on the syllabus you'll do the homework that's after week 2. So where it says week 2, that's the homework you do today. Okay? So the homework is for after class that's numbered there.
29.5.
Tommy, you gotta help him. You just trust him? I mean, I appreciate your trust, but... So let's turn over to page 17, please. So what you see in this lab is how these conversions actually work, even on a very practical scale. That's what we were trying to establish there. Now on page 17, he mentions that we also have metric units in temperature. And then we have what we would consider English units, which is what we use. If I were to say to you that it's 85 degrees outside, what measurement would that actually be? 85 degrees what? Does anybody know? Fahrenheit. Very good. Fahrenheit is what we use here in the United States. In other countries where they use the metric system, they use Celsius. And they use Celsius because, once again, it's based on the 10-point scale, so it's that easy way. It used to be called centigrade, centi for 100. And they call it Celsius in honor of Celsius, who actually came up with the scale. But it's centigrade used to be its name because 0 was where water freezes and 100 degrees centigrade was where water boils. And then they just divided it in between. And that was the centigrade scale that was developed by Celsius. And so we call it Celsius. Fahrenheit developed the one we use. What temperature in Fahrenheit does water freeze at?
32.
Good, 32. Where does it boil? Do you guys know? 212. 212. And this is Fahrenheit, this is Celsius. Don't write centigrade, it's old. I'm old. Okay? They call it Celsius now, but you understand where it's based on 10, and that's why they use it with the metric system. How many of you have ever been to another country, either visiting or on a mission trip or something? Okay. And did you notice there that they gave what the temperature was in Celsius, and you look at the temperature and you go, it's not 25 degrees outside. Right? It's hot outside. And then you go, oh, 25 degrees Celsius. Well, that's like 70 something, you know. And so when we were in Europe, they'd say it's 7 degrees. 7, you know, one digit, 7. And I'd be, And really it was reasonable outside because it was the Celsius scale. It wasn't the Fahrenheit scale where 7 would be, So there are these differences, and we're the only people in the world that use Fahrenheit. So if you ever travel, you'll experience those differences. Okay. Yes.
So it's more of a variety in the smaller numbers?
Yes, it's a tighter scale, as I showed you, because we have from 32 to 212 for, from freezing to boiling. So yeah, it's a smaller scale and therefore bigger changes between the different digits.
Do they still use negatives?
Yes. Yes, they do.
Probably not.
Yes. And believe it or not, when you get to chemistry, there's a third scale that you use, which is Kelvin. And we're just not going to go there right now. But there's at least 3 that you can use. So, okay. All right, on page 17, the next thing we get into is concentration. And so why don't, Christiana, would you read for us what concentration is, please, ma'am?
The quantity of a substance within a certain volume.
Thank you. And so quantity in a volume is all you have to say for a definition, okay? Quantity in a volume. Because it tells you how much of something in a particular volume. And so you guys are all familiar with concentration. How many of you have ever taken, I hope you haven't, but how many of you have ever taken Minute Maid pink lemonade that's frozen in the can? You've ever had that? It's really good, isn't it? And you're supposed to take it and you're supposed to dump it in a pitcher and then do 3 things of water with it, right? I used to get it out and eat it with a spoon. I liked it concentrated. I love sour things. It makes my mouth water just thinking about it. Because to me, that was like like a snow cone or something. I just, talk about fattening. That was back when I was young and I could do stuff like that. Probably rotted my teeth too, and I didn't know it, full of sugar and acid. Oh my goodness, as a parent now I think of that and go, oh. But that's very concentrated. And then when you put more water in it, it dilutes it out. Because what have we done? We have taken the quantity in a volume and we've spread it over a greater volume, haven't we? So it's less concentrated. And the example that we have here is we have an experiment, and it's not in your syllabus. It was not required for you to write up, so don't panic. I just want to show it to you because I think it helps to make the point. So what you have close to you, not right on top of you, because do you know how many ball jars this is? It's like 24 ball jars as it is. So everybody's got one where you can see it. You people will look at theirs. You ladies will look at the ones right behind you, okay? All right. And what you have, each of these ball jars was marked. They'll either be marked at the 1 cup place, or they'll be marked at a 1/2 cup. You'll notice that. Or they'll be marked at a 1/4 cup down here. Okay? Now, each of these was filled with vinegar to where the mark is on the jar. And so the first ones you're supposed to use, and you're going to have to help me, you people at your tables. You each also have Tums at your tables. First, don't do the ones with water in them. Do the ones that are 3 different levels. Those are strictly vinegar. The first one has 1 cup of vinegar. You're going to drop a Tums in. The second one has a 1/2 cup of vinegar. You're going to drop a Tums in. And the third one has a 1/4 cup of vinegar. And you're going to drop a Tums in. Okay, notice that all the Tums are the same colors. If you students at home are trying to do this, it is most important that you have the same color Tums. I have seen different colored Tums seem to bubble differently. I don't know why. And the color just seems to mess people up. So make sure that you have the same colors. Now, if you will notice, and this one's got the 1 cup, this one's got the 1/2 cup. I'm going to try to hold all these up here. And this one's got the 1/4 cup. Nope, I got them backwards, don't I? Oh, this is fun. Okay. I want you to notice if you can see the bubbles, and look at the one close to you if you can. If you can see the bubbles on the Tums, are there any real differences in the amount of bubbles on the Tums of these 3? No, and I'm going to set these down for you guys. Now, next trick. These 3 that are the same height, but they have different marks, wherever the mark is, that was where the vinegar is up to. But they've all been brought to the same volume, haven't they? So they have the same volume, but this one has a cup of vinegar, this one has a 1/2 cup of vinegar. And this one has a 1/4 cup of vinegar. So that means that this one is less, this one's more concentrated than this one, isn't it? This one has much more water in it than this one does, correct? Now go ahead and put your Tums in those. 1, 2, 3. Okay. Now these, it's a little trickier. You got to go ahead and put your top back on. And go ahead and swish. Don't shake. Just swish. Everybody that is close to it, take a look and see if you see any differences in the bubbles. Basically, the number of bubbles in the different glasses.
Well, now, but wait a minute, Adam. What did the bubbles represent? They represent the actual carbon dioxide that's coming off the chemical reaction, right? So it's really a good measure of how much activity's going on chemically.
Okay, which one has the most bubbles? Is it the one with the largest amount of vinegar or smallest? No, I'm not talking about, don't compare them with the ones with no water. Go over just to those three that they have the same amount of water, the same volume in each of them. Okay, the largest amount of vinegar has more bubbles or less bubbles? Okay, the largest amount of vinegar, let me just hold these up. Notice this one has a cup of vinegar. This one has a 1/2 cup. This one has more bubbles than this one. If you counted the bubbles, this one would have more because this is more concentrated. This has less vinegar in the same amount of volume, and the 1/4 cup has even less bubbles. I think it's got like 4 or 5 on the whole thing. And that's because in the same 2-cup volume, it's only got a 1/4 of a cup of the vinegar. Now what this experiment is supposed to be showing you is that concentration affects how things not only taste like the Minute Maid lemonade, but also how they work, right? And if you've ever used, okay, you all used hydrogen peroxide at some point in time. Maybe you had a cut and your mom poured hydrogen peroxide on it, or you used it for something. Regular hydrogen peroxide at the store is 3%. It's 3% of it is hydrogen peroxide, and it's diluted with water. You can get food grade hydrogen peroxide that's 35%. If you put it on your skin, it'll burn because it's so strong. So the difference is, okay, I get you another one. Acid. Really strong acids will burn your skin, they'll burn the table, they'll just go right through things. When I was in college and doing upper level chemistry labs, the acids were and the bases were so strong that they poured like syrup. And they were kept in a fume hood because the fumes were deadly. They were kept in a fume hood, and you weren't allowed to carry them anyplace. You had to work with them right in the fume hood, and right next to the fume hood was the shower, because if it attacked you, you could jump in the shower immediately, which happened to me once. I had to go into the bottom of my graduated cylinder, and there must have been some residue left in it because it looked empty, and it was sulfuric acid. I will never forget that because the sulfuric acid went to the bottom and shot right back out all over me. And then there were people behind me waiting to get their sulfuric acid, and I almost knocked them down jumping into the sink with the shower. You know, one of those big sinks, and I'm like jumping in it, you know, and then I also learned you never wear your favorite jeans to a chemistry lab, because after I washed those jeans, they were full of holes, and I was so upset because that was back in the 70s, and those jeans had gold stitching down the side, and at that time it was very hard to find pants like that. I had gone all the way to Atlanta to get those back in the day, and I was so upset that my jeans died, you know. So anyway, never wear your best clothes to a chemistry lab. But concentrated acids and bases can be very, very dangerous, whereas if you clean the toilet, you're using acid when you clean the toilet. It's not that concentrated. It's diluted so that you can do that. A diluted base would be bleach that they put, chlorine bleach, that they put into your drinking water. Why is it supposed to be safe? Because it's supposed to be a low concentration. I want you to notice I keep saying supposed to be. Because I don't know if I agree with all that stuff, and I don't drink chlorinated water unless I'm dying and have to. Because I really think that it does build up after a while. The concentration actually does build up if you continue to expose yourself to it for long periods of time. If you shower in it for extensive periods of time, then eventually your body does actually start building up the concentrations. But that's politically incorrect. But you guys all know I'm politically incorrect, so just, you know. Okay, and then on page 19, he says that certain vitamins I was taught this too, and once again, I have to disagree with him here. Fat-soluble vitamins, when I was in college, we were all taught, including Jay Wiles, I think he's actually about my age, maybe a little younger, and at least he looked younger to me, but maybe he's just in really good shape. But he's probably close to my age because he has a married daughter also who I've met. But back when we were in college, they taught us just what he says here, that if you eat too much fat-soluble vitamins, that they'll build up in your fat cells, and therefore they can be very dangerous. And I was taught when I went to college that if you ate too much vitamin A, it would kill you. I even remember them teaching us that you can't eat polar bear liver. Well, like, who's going to eat polar bear liver? But anyway, you can't eat polar bear liver because it's got such a high vitamin A content that it would kill you. And then in the last couple of years, when I started getting into nutrition and studying nutrition, the biblical nutrition, and doing things the healthy way and not doing them what everybody else says, all of a sudden I start reading literature that we were lied to about the vitamin A, and that we can eat a whole lot more vitamin A. And as a matter of fact, we need more vitamin A, and that people are helping themselves get over cancer by eating a whole bunch of vitamin E and vitamin A and all these fat-soluble vitamins. Maybe you're aware that within the last year, all of a sudden they're telling everybody, you need to take vitamin D. I mean, all of a sudden my parents go to the doctors and they're being told, oh, you need to take 50,000 units of vitamin D a week. And I'm looking at my parents going, to say what? You know, because we were always taught here in Florida that you synthesize vitamin D yourself when you're outside. And so in Florida, everybody's told, don't take vitamin D. Don't ever take anything with vitamin D in it, because if you get too much, it's toxic because of the high concentrations. And now all of a sudden they're telling everybody, take vitamin D. You don't have enough vitamin D. Matter of fact, you have to take K so that you can absorb the D. This is all like totally different than what we were taught when we were in school. I just want you to be aware of that. Okay, now I'm not trying to confuse you. The thing I will tell you is, you've never had me for nutrition, so just listen closely. Eat what God made to be food. Eat it the way God meant for you to eat it. And don't let foods be your idols. So if you're like a Twinkie addict, that's not good. Okay? Okay. And so you don't have to panic. Keep that in mind. I'm just telling you, one of the things you learn from what I just told you is that scientific interpretations are constantly changing. They're constantly changing. God's word's not. Where are you going to base your life? Better be on God's word, right? Because it's perfect, and the scientific interpretation is only as good as the people that are doing them. Ouch! Right? So be aware of that. Second off, this was applied here as far as concentration, and all of a sudden I'm telling you that the concentrations, yes, they do matter. Okay, I'll give you one that I know is to be true. How's that? Vitamin C is a water-soluble vitamin. So you can take way too much vitamin C. It won't make you necessarily sick. What it'll do is when you urinate, your kidneys will hurt. Your kidneys will actually hurt. Your body will say, too much vitamin C, stupid. Okay? And your kidneys will actually ache when you do it. Now, it won't actually hurt your kidneys. Your kidneys are telling you, stupid, you took too much vitamin C. Some people might even have indigestion if they take too much vitamin C. Why would somebody take too much vitamin C? That was the original way to take down edema. Before they had swelling, before they had all the drugs, anti-swelling drugs. Actually, it's a very natural way to take down swelling. If you have swelling and you don't have anything else available, you take high doses of vitamin C and a lot of water, the swelling will go away. Worst thing that will happen is it'll ache a little bit when you urinate, and it works, okay? That can be very helpful in an emergency situation. My mom is allergic to, we skin dive, and my mom's allergic to the little particles that come off of the man-o-war certain times a year. Have you ever been in the water and you feel like you're getting stung? Okay, and it's the man-o-war particles. And she was very allergic, and we were in the Bahamas. I mean, like nowhere, in a 24-foot boat in the Bahamas, and she's swelling up like crazy because these things are hitting her. So a pharmacist told her, take with you fast-acting vitamin C, take it, and he told her, like, take 4,000 units. That's a lot of vitamin C all at once. And that used to be how she got through it on the boat. If she got this allergic reaction, she would take 4,000 or 5,000 units of vitamin C, drink a lot of water, and then you could watch the swelling go down. So that's a very cool little thing to know about. And that's not a normal concentration, is it? You wouldn't want to do that on a regular basis. That would be woo. But it's helpful to know that. People that are fighting cancer, once again, they might take 20,000 units a day of vitamin E. How many of you have ever heard of somebody doing something like that to fight a disease? I have. I've known people that do that. Vitamin A is another one. These exact ones that they tell you don't take too much of. Sometime if you take large doses when you're fighting cancer, God bless you. Don't do it just willy-nilly. Have somebody that's actually directing you through it. Hopefully none of you are fighting cancer. But that can actually help, because these high concentrations can do weird things, you know. Yes, ma'am.
If you like don't have as much of swelling or whatever, if you're like swimming or snorkeling, you get bit by stuff and it swells up, could you take smaller amounts to make the swelling go down? Or?
Yes, you could. You could. But you want to take not the time release stuff. You want to take the fast acting stuff. Guys, if you ever get stung in the water, you should always have vinegar around. It's one of those things that you should carry in your beach bag or on your boat, because if you get stung and you hit it immediately, spray it with vinegar, it will denature the toxin and will help you right away. It will help you. Works on ant bites. I don't know if you've ever seen the movie My Big Fat Greek Wedding, but you know how he is with the Windex? That's how my dad is with vinegar. It's like, well, did you spray it with vinegar? And you know, it's frustrating because as I got older, I found out my dad was right. You know, it's like you want him to go, no, Dad, that's not true. I'm the science major. My dad was right. So the vinegar really does work, and so you want to keep it around. Okay, so concentration, it matters. Now, the other one he did was secondhand smoke here, and he said that, you know, people that did secondhand smoke didn't usually get cancer from the secondhand smoke. But honestly, people are allergic to secondhand smoke. I know there are a lot of them in my own family that are allergic to secondhand smoke, so forget the cancer. You might just not be able to breathe and die anyway if somebody's smoking, you know. So, but what he's saying there is that the concentration really makes a big difference, and it does. Okay. So let's go over to page 20, and we need to read 1.9, and actually it's Courtney's turn, and Courtney, that first word is muriatic, and if you want, I'll say the names of the acids if you want to hesitate there.
Muriatic acid is sold in hardware stores for use in cleaning. Pool owners, for example, use it to clean hard water stains and algae stains from their pools. Its active ingredient is hydrochloric acid. The Works is a toilet bowl cleaner with hydrochloric acid as its active ingredient. There are approximately 350 grams of hydrochloric acid in a liter of muriatic acid, and there are approximately 30 grams of hydrochloric acid in a liter of the Works. Why is muriatic acid a more powerful cleaner than the Works?
It's much more concentrated. You got the hardest one to read. Okay, I just want to say that, and you did a really nice job. It's more concentrated, isn't it? If it has 350 grams per liter compared to 30 grams per liter, it's a lot more concentrated, isn't it? My husband actually keeps some muriatic acid around, and we don't mess with it. And every once in a while, like twice a year, he'll come in and do the toilet bowls with it and the faucets, because we live in the country, and so our water's very, 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 very hard, and I can't get it all out with just regular Comet or the Works or any of those things. So he puts this hardcore stuff in there, and I'm telling you, I have to leave the house. The smell is so strong, it will burn your eyes and your mouth when you try to breathe, you know, your nose. I don't know how he stands it. So he's tough, you know, he's a guy, he's tough. But it really does a difference, and it's very dangerous because of that higher concentration. If you got it on yourself, it would take your skin off too, or it would ruin your best jeans. Anyway, okay, all right. Would you read 110 for us, please?
Sodium is a necessary part of a healthy diet. If a person does not ingest enough sodium every day, that person will get sick and perhaps die. Nevertheless, some people try to limit their sodium intake by eating a low-salt diet. How can it be good to limit your sodium intake, even though sodium is a necessary part of your body chemistry?
Go ahead. You want to give it a shot? Or you want somebody else to help you?
Yeah.
Okay. Who wants to help her with that? Yes, Drew.
Because if you take too much, it becomes way too much. Becomes too concentrated.
Good, good.
Becomes
Very good. If it becomes too concentrated in your system, then it can become toxic. Just a little heads up here, because once again, some of you know that, some of you don't know me, but I teach biblical nutrition, and so I'm real strange about food. If you ever watch me eat lunch, you're going to really say how strange. Oh my gosh, it's really weird. And it's cool. I am, you know. But I want to give you the heads up. The reason why people have high sodium in their diets and the concentration, and therefore they have to watch their sodium, is because they're eating a lot of processed foods. If you eat foods that are made from scratch, you can eat salt on your food. That's why some of you may have great-grandfathers or something that lived to 105 and they always ate salt and, you know, did all the weird bad stuff. It's because their food was closer to the way it was originally intended to be eaten. Whereas if you're living on like ramen noodles Watch the sodium concentration on that. Read it sometime. Just open your mouth and pour in the salt, okay? The sodium concentration on some of that stuff is incredibly high, and it's got to do with processed foods. And that's why if people are eating processed foods, then they have to start watching their sodium intake, because the concentrations they get, it's incredible. And so, once again, if you're eating normal, natural, I eat grapes and cheese and normal stuff, like food that God meant to be food, you won't have to worry so much about sodium. But if you're eating processed foods, you really have to concern yourself with that. And actually the sugar content, oh my goodness, that's a scary thing. But anyway, okay, let's go over to page 24, please. I just want to give you the heads up. We're going to do this together. You need to be able to answer all the questions on your study guide without looking. And when you can do that, you know you're ready to take your test. If there's anything on your study guide that when you look at it, you think, oh, I don't think I could have answered that right now without looking at the book, you're not ready to take the test yet. So go back and study it. Make sure that you can do all the problems, that you can answer all the questions without looking back at the textbook. Then you know you're ready. Okay, so we're going to go through these.
Even the ones with the numbers?
Yes. Oh, now he'll give you the numbers, but you have to be able to do them without looking back to figure out how. Yes. And he promised that thank you God, he would give us the conversions like from 1 inch equals 2.54 centimeters. He'll give you those. You don't have to memorize those. Anytime you don't see something that he's supposed to give you, look under the word test. I notice he hides things there. And I say that because, I don't know about you, but I never look at the word test. And I'll be looking all over the test going, where is it? You know, and it's right there at the top. So if you ever can't find something on one of Jay Wild's tests that's supposed to be there, look under the word test. Okay. But we're going to go through this before. I'm just going to say this because I'm thinking about it right now. Before you take the test, make sure that you can answer all these questions. Make sure that you've written up any labs that you're supposed to write up. And we've all at least gone over and discussed the other labs because he expects you to have that information when you take the test. Okay? If you're taking this class for credit, which I'm going to assume that all of you are for high school credit, then that means that you are not supposed to use the book to help you for the test. You're supposed to have this and know it, and then you close the book and you go pray and you go someplace quietly and you take your calculator with you. Make sure you don't do these without a calculator. I'm telling you to tell your parents you must have a calculator. Okay? This is not arithmetic. This is science. And so take your calculator with you. I would suggest you do all your math problems at least twice before you feel comfortable leaving it alone, because if you push the numbers wrong, okay? And make sure you write out everything with the units so that I can see your work in case you do punch something wrong. I can give you partial credit. Does everybody understand? Jay Wiles is notorious at making short tests. I love Jay and I love his books, but his tests are short. And some of you are going, oh, that's great. Well, if you got 15 problems on a test and you miss one, you just lost a quick 8 points. Ouch. So you want to be very careful, okay? Ooh. And that brings up another thing. If you want to write up labs that we didn't have to write up in class, they're worth one test question. So on the lab 1.3 with the concentration, if you wanted to write that up, so you'd write up the purpose, procedure, you know, the observations, and the conclusion, then you get however much a test question is worth, you get that many points on your test. Okay, and you live students need to bring it in and show it to me. You home students need to show it to your mom and show them that you've done the full, you know, 4 things, and that you can show her this part, that it is worth a full test question. I don't know what that is right now, but that's what it's worth, so that you can add that onto your test. Okay, so everybody's aware of that and you have that opportunity. So if you know you're having trouble, you can do extra labs. Yay! Okay. Yes?
So you can't do more than one lab?
Oh, sure. Anytime you do extra labs, they will count as extra credit on your test if you write them up. So please bring them in and show me. Okay? Great. All right, let's go ahead and go through the study guide so that we can make sure you're ready for that. So it's your turn, right? I think it's your turn.
Read the definition for the following
Just the first one. Would you do the first one for us, please? An atom?
Oh, yeah. Okay. It's the smallest living chemical.
It's the smallest chemical unit or unit of chemistry. You don't have to have this memorized now. You have to have it memorized to take the test. And like I said when we started, in the pedagogy in the book, he says that he wants you to have it memorized his word for word, and that is insane. So I don't want you to do that. So yes, I will happily talk to your mom, or she can read that in the syllabus. It's your choice, okay? You online students, make sure your mom reads that so you don't get in trouble. And your study guides should never count against you. Your study guides are for your benefit. And I really don't want you to memorize his words, because you'll forget them. In 2 weeks, you won't remember a thing. But if you do it in your own words, you have a hope of remembering some of this. And so it's really important, okay? All right, so an atom was, go ahead, tell me what an atom is.
It's the smallest chemical matter ever. And then, yeah.
Okay, it's the smallest chemical unit in matter. Thank you. How about a molecule, Luke?
I'm missing a page.
Do you remember what a molecule is?
Two or more atoms combined.
See, I knew you could do it. Good job. 2 or more atoms that are combined. You don't have to write it, but in your head you need to know that they can have unique characteristic properties with whatever changes. So know that for your head. Okay? How about concentration?
The quantity of
You're right on the right track. The quantity
of a substance is a certain value.
of volume. So what you can just say is quantity in a volume. That's all you have to do. Quantity in a volume is good. That tells me you know what you're talking about. Okay? Great. All right. John, would you read number 2 for us, please?
50 grams of carbon disulfide can be broken down into 42.1 grams of sulfur and 7.9 grams of carbon. Is carbon disulfide made of atoms or molecules?
What do you think? Molecules. Very good. Carbon disulfide is made up of molecules, and that's where we were able to break it down into sulfur and carbon. So don't say, but everything's made up of atoms. You're overthinking it. Don't do that. Okay, just they're molecules if you can break it down. And it doesn't blow up on you, or make a nuclear bomb. Anyway. Okay. Austin, would you read number 3, please?
If you put iron near a magnet, the iron will be attracted to the magnet. Rust is made up of molecules that contain iron atoms and oxygen atoms. Rust is not attracted to a magnet. If rust contains iron atoms and iron is attracted to a magnet, why isn't rust attracted to a magnet? It's like, because I guess when you have another atom combined to it, it changes its form, so then it's a totally different substance, so it's unattracted.
Very good. It's a new molecule, and therefore it has unique properties. It's not the original molecule. And that's what you just said. I got it out of that. And so write down everything, and never leave an answer blank on a test. Never leave an answer blank on a test. If you really don't know, but write down everything you know about it. I've had students get them right that way. They've had whole paragraphs, but in there somewhere was the answer. Okay? And if it's there somewhere, that's cool. So just make sure you answer all the questions. At least try. Okay, great. Thank you for that. Bobby.
Number 4.
Yes, please.
A statue is made out of copper and displayed outside. After many years, what color will the statue be? Blue?
Good. Blue, green, turquoise, teal. Nobody wants to spell turquoise. You can go with teal. It's short. And so you could even write bluish green, greenish blue. I don't care. Get one of those. The opposite is true. If you were to go and see a turquoise-colored monument and you were to scrape off the turquoise, what color would it be underneath? Copper color. You could say brown, reddish brown, penny colored, copper colored. Just something that tells me you know what you're talking about. I'm good. Okay? Thank you very much. All right. Let's do the next one, please.
Have scientists actually seen atoms? No.
Wait a minute. Do we have a problem back here?
No, I just wanted to know what he said for 3. Because I wrote it, but...
Number 3 was that you have a new molecule, and so you have new characteristic properties.
Okay.
Something about that.
Okay.
Great. I'm sorry. Would you start us again, please?
Have scientists actually seen atoms? No.
That's like cheating. It was too easy. Okay, no. All right, thank you. Carson, would you do the next one, please?
Yeah, the
numerical.
Yeah, numerical meaning for the preference says centi, milli, and kilo.
Good. What's centi mean?
1/100.
Very good. How about milli?
1/1000.
Very good. And how about kilo?
It's like 1,000.
Times 1,000. Very good. And actually, each of them are times, aren't they? They're times 1/100th, times 1/1000th, times 1,000. Okay, you have to know that. It's on the test. Can't be any clearer than that. Okay, thank you very much. Brianna, would you read number 7 for us, please?
Okay. If you wanted to measure an object's mass, what metric unit would you use? What English unit would you use?
Okay, so metric for mass, which would that be?
That would be a gram.
Good, grams. And what about the English unit? Good, slugs. So, Becky, for volume, what metric unit would you use?
Liters.
Good, and what English unit would you use? Very good. And Mallory, for length, what metric unit would you use? Good, and what English unit would you use? Feet. And you have to know those on your test. I just can't be any clearer than that. You have to know them. Thank you. Okay, let's see. Would you just read number 10 for us? I'll do it up here.
How many centimeters are in 1.3 meters?
Thank you. So we have, the given is 1.3 meters, and we want to know how many centimeters there are in that. So we write the given and the get to. Then we're going to write the given again. Did I do it wrong? No, we're okay, right? Yeah. Write the given again. What's next, class? Good. Times line. What goes down here?
Meters.
Meters. Guys, whatever's here has to go here. What goes up here? Centimeters. Who gets the 1? Meters. Meters are this long. Centimeters are this long. Okay? So meters, what does this get? 100. Okay, then you're going to use your calculator because I don't want you messing up just because you didn't use the calculator. So it's going to be this, because this is going to cancel and you'll be left with centimeters. But use your calculator so that you don't, hey, take a chance on messing up. Show me all that work. That should all be on there. If I just have this right answer and nothing else is there, you're going to miss most of the problem. So show me your work. If you do it on a dinner napkin, attach the dinner napkin to your test, okay? Show me your work. All right. Would you read the next one, please?
If a person has a mass of 75 grams, what is his or her mass in grams?
Thank you. So we have 75 kilograms, and we want to know what that would be in grams. So we're going to write the given again, times line. What goes down here? Good. Kilograms. What goes up here? Who gets the 1?
Kilograms.
Kilograms. So what does he get? 1,000. So that's going to be 75,000 grams, because that's going to cancel. How we doing? Okay? All right, Savannah, would you read the next one, please?
How many liters of milk are in 0.5 gallons of milk?
Thank you. And so we have 0.5 gallons. We want to know how many liters, and we're going to write this again. We're not going to panic, but he actually gave it to us right there, so we know it's there. What goes down here?
Gallons.
What goes up here?
Liters.
What number goes next to liters? Look at your book. What number goes next to liters?
3.78.
Good. What number goes next to gallons? 1. Okay. And so then you're going to, where's my calculator? There's no way I'm doing that one in my head. It's actually a half, just under a half of 4 though, isn't it? 3.78 times 0.5 equals, yep, 1.89 liters. Now, if, I'm sorry?
That's right.
That's what mine said.
Yeah, that's right.
Yes.
Okay. If you show everything and you get close, I'm going to count it as right. So don't get crazy about all the digits. Okay? Just show me all your work and then plug it in your calculator twice so you know you're reasonably close. All right? In chemistry, I get to torture you about your digits. In here, no way. So, okay, let's do the next one, please, Mariah.
A meter stick is 100 centimeters long. How long is it in inches?
Thank you. 100 centimeters long. We want to know how many inches it is. We're going to write the given again. Times line. What goes down here? Okay, what goes up here? Inches. And then what number goes next to inches?
154.
Look, what number goes next to inches? Everybody look. 1 is next to inches, so 1 will go next to inches here. What number is next to centimeters? So it will also go here. Be very, very careful with that. Okay, so we'll go 100 divided by 2.54, and we have 39.37, and that will be inches because our centimeters will leave. Okay? Is this what you guys got? Okay. So, Solomon, would you read 14 for us, please?
Ozone is a poisonous gas that can build up in the air, in dense sites. Thus, there are many.
That's, yeah, environmental initiatives.
To lower the amount of ozone in the air we breathe. One way you can make ozone, however, is by baking bread. The nice smell you associate with baking bread is actually due in part to ozone. If ozone is poisonous, why is baking bread not considered a dangerous activity?
What do you think?
Once again, because like the molecules are being changed, so they have different characteristics.
Actually here, that's good, but think here. If I bake bread and ozone is in my house, and you walk in my house, you shouldn't die. Breaking bread in my house can be dangerous. I just want you to know that. But you shouldn't die. Whereas if you walked into a position where there was way too much ozone, you probably would die. Why would that be?
Because it's too high of concentration.
Very good. So it would be too high a concentration. Very good. I want you to know baking bread in some homes is dangerous. I just want you to know that. Okay. So, and like I said, in my home it can be. All right. So that would be the concentration. Thank you. Now, don't move. So what you're going to do is you're going to make sure you've written up your labs. You're going to study the study guide. You're going to take your test and then follow the syllabus, and you're going to do the first half of the next module. Do you have any questions that we've gone over? Are you okay? Okay. All right. Have a Jesus-filled week.